Hello everyone. Today you will learn about binary numeral system. I'll give you first a very short story.
A long, long time ago, from a planet far, far away, an alien left his home in search of adventure. He hopped in his spaceship and travelled the solar system for many years. Meanwhile, a little girl sleeps. She sleeps soundly in her bed until she awakes to tapping on her window. Imagine her surprise when she looks out her window and sees an alien standing there. At first, the girl wonders what the alien wants, but then the alien waves to her and starts to speak. The girl thinks back to what Mrs. Hawley had taught her at school and recalls that every letter can be represented by a binary number. She remembers that by using a table, she can work out what this binary number represents. She works out the first letter is H and the second letter is I. The alien had said hi. The girl responds, "Hi, it is so nice to meet you." And the alien smiles and starts to speak some more. Suddenly, somewhere, an alarm clock rings and the girl awakens from her dream.
The binary, base 2 numerical system has two possible values, often represented as 0 or 1, for each place value. In contrast, the decimal, base 10, numeral system has 10 possible values, 0, 1, 2, 3, to 9, for each place value. To avoid confusion while using different numeral systems, the base of each number may be specified by writing it as a subscript of the number. For example, the binary number may be specified as base 2 by writing it as the decimal number 156 may be written as and read as 156, base 10. In converting, you have to remember the powers of 2. 2 to the 0 equals 1. 2 to the 1 equals 2. 2 to the 2 equals 4. 2 to the 3 equals 8. 2 to the 4 equals 16. 2 to the 5 equals 32. 2 to the 6 equals 64. 2 to the 7 equals 128. 2 to the 8 equals 156. If you memorize at least this and make them second nature to you, can do any conversion very quickly, but of course you can move any further if you want, and if you are told to do so. Example time. Let's try binary to decimal conversion. Let's say we want to convert the binary number to decimal. First, write it down. Then, write down the powers of 2 from right to left. Start at 2 to the 0, evaluating it as 1. Increment the exponent by 1 for each power. Stop when the amount of elements in the list is equal to the amount of digits in the binary number. Starting from the right, write each consecutive digit of the binary number to the power of 2 that is next in the list above it. The example number, 100111011, has 8 digits, so the list, with 8 elements, would look like this: 128, 64, 32, 16. Move through each digit of the binary number. If the digit is a 1, write its corresponding power of 2 below the line, under the digit. If the digit is a 0, write a 0 below the line, under the digit. Since 1 corresponds with 1, it becomes a 1. Since 2 corresponds with 1, it becomes a 2. Since 4 corresponds with 0, it becomes 0. Since 8 corresponds with 1, it becomes 8, and since 16 corresponds with 1, it becomes 16. 32 inches corresponds with 0 and becomes 0, and 64 corresponds with 0 and therefore becomes 0, while 128 corresponds with 1 and becomes 128. Now, add up the numbers written below the line. Here's what you do: 128 plus 0 plus 0 plus 16 plus 8 plus 0 plus 2 plus 1 equals 155. This is the decimal equivalent of the binary number 100111011. Now, let's move on to decimal to binary conversion. We will use binary number 211 in our example. First, draw out a conversion table. Is 211 larger than 128? If yes, put a 1 underneath 128 in the table. If not, leave it at 0. As we put a 1 under 128, subtract 128 from 211 to see what is left. We have 83 left. Is 83 larger than 64? If yes, put a 1 in the space under 64. If not, leave it at 0. We started with 83 and we put a 1 under 64. Thus, subtract 64 from 83 to see what is left. 83 minus 64 equals 19. We have 19 left. Is 19 larger than 32? If yes, put a 1 in the space under 32. If not, leave it at 0. As 19 was not larger than 32, we left it at 0. Is 19 larger than 16? If yes, put a 1 in the space under 16. If not, leave it at 0. We started with 19 and we put a 1 under 16. Thus, subtract 16 from 19 to see what is left. We have 3 left. Is 3 larger than 8? If yes, put a 1 in the space under 8. If not, leave it at 0. As 3 was not larger than 8, we left it at 0. Is 3 larger than 4? If yes, put a 1 in th. As 3 was not larger than 4, we left it at 0. Is 3 larger than 2? If yes, put a 1 in the space under 2. If not, leave it at 0. We started with 3 and we put a 1 under 2. Thus, subtract 2 from 3 to see what is left. 3 minus 2 equals 1. Using the method, the binary number has been converted into binary 11010011.